All right, looks like we're doing Trig lecture 929 and 930. And in this lecture, the student will determine the quadrant in which the terminal side of a given angle lies. The given angle will be in standard position. And in standard position, the initial side of our angle will be the positive x-axis. And then we'll rotate in either a positive direction or a negative direction so far, and then we will stop and determine which quadrant we're in. These are the quadrants, the axes, the x-axis and the y-axis, chop the plane into 4 quadrants. Quadrant 1 is right here. Quadrant 2, Q2, capital Q, Roman numeral 2. Quadrant 3 is right here. And quadrant 4. So let's say I said 100 degrees. What quadrant does 100 degrees stop in? Well, how I would think of it, the way I would think of it is, well, here's from here to here is 90 degrees. If I'm rotating, that's a rotation of 90 degrees. If I go 10 more degrees, it'd be somewhere in here, and my answer would be quadrant 2. Just that simple. Remember that when you're rotating in a positive or negative direction, you can just count by 90s. 90, here's a rotation of 180 degrees, plus 90 would be 270, plus 90 would be 360. And you can just remember that each of these axes is a rotation of another of 90 more degrees. You can keep that in mind as you're counting and determining which quadrant your angle is going to stop in. The initial side will always be the positive x-axis. The terminal side will be wherever we stop when we rotate as far as is indicated by the problem. And here's what that's going to look like. State the quadrant in which the terminal side of each angle lies. Okay? My terminal side of a 200-degree angle. The initial side is going to be the positive x-axis. I want to rotate 200 degrees. Well, I know that rotating from here to here is 90. If I rotate 90 more, that's 180 degrees. If I want to go to 200, I'm going to go 180 plus 20 degrees, which will be something like this. That's a rotation of approximately, it's a rough approximation, but it's not too far off. The answer that I'm looking for is the quadrant in which the terminal side lies. Well, this is quadrant 1, this is quadrant 2. Here's the terminal side. The terminal side lies in quadrant 3. So that's my answer. It's quadrant 3. Very simple, straightforward stuff. Let's take a look at another one. Negative, that means we're going to be rotating in this direction, clockwise, 470 degrees. So let's see how we would do that. I'll show you how I would do it. There's my initial side. I'm going to rotate negative 470 degrees. Well, here's negative 360 degrees. I want one full rotation. Just one, all this is a direction of, it indicates the direction of rotation. I'm going like this. Here's 360. If I go 90 more, that would be 450, negative 450. Now I've got to go 20 more to get to negative 470. So it'd be something like this. Now the accuracy of your sketch doesn't matter as much as the quadrant in which you stop. It's kind of messy. Make it look a bit better. Well, that didn't help, did it? I'm going to go 20 more degrees. That's fairly close. We said, okay, 360 going in a negative direction. Another 90 is 450 degrees. 360 plus 90 is 450. 470 would put me into quadrant 3. So my answer is quadrant 3 again. Just a coincidence. And this was just some sloppiness there. All right. So let's take another look at another one. Taking a look at another one. Here we go. 7 pi over 12, so we're in radians now. I will teach you how to rotate in radians later, because most kids like to convert their radians to degrees and then just do what we did up here. So that's what we're going to learn first, and then I'll show you how to count in radians. Okay, so most kids would go like this. So I don't want to rotate in radians. I'm going to do this. And they would start canceling, or they put this into their calculator. And this would be 7 times, these will divide by 12, that'll become a 1, that'll become a 15. And 7 times 15, I'm afraid to do that in my head, I'm going to get 105. Let's see if that's correct. 7 times 15 equals 105, yay! So 7 pi over 12 radians is 105 degrees. The exact same rotation. So here's my initial side, the positive x-axis. I'm going to rotate positive 105 degrees, which is 7 pi over 12, because I just did the conversion. Well, here's 90 degrees. To get to 105, I'll have to go another 15 degrees or so, which that's a rough sketch. But the important part is I clearly am going to have to stop in quadrant 2. That's the response we're looking for. Okay, and let's see if I got it right. Yay, quadrant 2. Okie dokie. Negative 28 pi over 9. One more to go. Again, I'm going to go ahead and convert it into degrees for you, rotate, and determine the quadrant in which the terminal side stops. So here we go. I'm going to say 180 over pi. These pi's will cancel. Pi divided by pi is 1. So when we cancel it out, it becomes a 1. 9 will go into 180 20 times. So that divide that by 9, it turns into a 1. Divide that by 9, it turns into a 20. And then we multiply 28 times 20, which I believe is 560. And it'll be negative. And I'll check that with my calculator. I converted my radians to degrees, and now I'll rotate negative 560 and try not to mess it up. No promises. 20 equals 560. Let me try that. 28 times equals divided by 9 equals. Tried it twice, got 560 both times, so that's probably right. So here we go. My initial side is the positive x-axis. I want to rotate in a negative direction, 560 degrees. Well, here's 360. I'm just going, this is just the direction of rotation. There's the arrows going this way. It's not supposed to be a circle, it's just indicating which direction I'm rotating. So I've rotated 360. If I go another 90 degrees, that's 450. If I go another 90 degrees, that's 540. There's 540, just adding 90s. And then I've got to go another 20 to get to 560. So, and that would put me in quadrant 2 if I haven't made a mistake. I'm going to count that off again just to see. I'm looking for negative 560. And that will be negative 360, negative 450, negative 540. So negative 560 would put us somewhere in quadrant 2. Fairly close to the negative x-axis. So hopefully that's correct. Let's see if I got it right. Yay! That looks good. So there we are. I don't think I have any more on here. 2 of them stopped in quadrant 3 by coincidence. 2 of them stopped in quadrant 2. They can stop anywhere. You can do this.